Section 6.5, Solving Equations by Factoring. In the previous three sections, we reviewed how to factor different expressions. In this next section, 6.5, we're now going to see why that is a useful, skill to learn, and how it will help us solve different equations. In order to do this, we have to understand the zero product property, which is this idea that tells us if we multiply two things, in this case we're looking at a times b equals 0. So if we take the product of two things and we get 0, well then it tells us something about those two factors. Either a had to be equal to 0, or the other factor, b, had to equal 0. Okay, one way or another, one of those two values would have to equal 0 for their product to equal 0. It's the only way you could get 0 when you multiply. So, when we have expressions or an equation that's in a factored form like this on the left-hand side equal to 0, well then we can apply that zero product property. We can think of this parenthesis as our a, this parenthesis as our b. They are being multiplied. When you have two parentheses together, that implies multiplication. And we have the equation set equal to 0. So, in order to apply the zero product property, this tells us either this parenthesis, the x plus 6, would have to be equivalent to 0, or the other factor, the 2x minus 3, would have to equal 0. And then this becomes two linear situations, two linear equations that we can solve pretty easily. Here on the left, we'd subtract 6 from both sides to get that x is equal to negative 6. And then in our other equation, we'd want to add 3 to both sides to get 2x equals 3. And then divide by 2 on both sides, giving us a fraction, x equals 3/2. So solving this equation, we actually get two possible answers. 6 is the x value that would zero out this factor, the left parenthesis. 3/2 is the factor that if we plugged in for x would zero out that parenthesis. And either way, if we get a 0 in this parenthesis, 0 times no matter what this equals is going to equal 0. Or if we plug in 3/2 here, doesn't matter what this parenthesis equals, if we get a 0 here, anything times 0 will equal 0. So these are the two values that will zero out either of those two factors, which would make the product equal 0. Okay. The next example is a similar setup, although it might look a little different. Even though it is only a 5a, it technically is its own factor. So we can think of the 5a as one of the factors that has to equal 0. And it is being multiplied by this other factor, 2a plus b. When we multiply, we're getting the value 0, so this is good. We can split the two factors into their own equations, setting them equal to 0. So, either 5a equals 0 or 2a plus 8 equals 0. And then solving both of these, well here we'd want to divide on both sides by 5. And to get a by itself, and when you divide 0 by 5, well, and 0 divided by anything is going to give us 0. So it tells us one of our solutions to the equation is a equals 0. And then 2a plus 8, well, subtract 8 from both sides. That'd give us 2a equals negative 8. And then we would divide on both sides of that equation by 2 to get a by itself. And we get that a is equal to negative 4. So in this case, again, we get two possible solutions. Either a is equal to 0, because that would make this part equal 0, and then 0 times anything would equal 0. And if we plug in the negative 4 here, that'd give us a negative 8, plus 8 would make the parenthesis equal 0. So it doesn't matter what the 5 times that a value equals, because it's times a 0 when we multiply by the parenthesis, which will get us a product of 0. So again, these are the two values. If we plug them in here or in here, that will zero out this factor or zero out that factor. Okay. Our third example here, we have two factored parentheses, two binomials, x plus 7 times the value x minus 4 equals 6. Well, we have an issue here. We can't apply the zero product property because this equation is not set equal to 0. Okay. And a common mistake some of my students in past have made is that they kind of apply the same idea. Well, a parenthesis times a parenthesis equaling 6, maybe that means that x plus 7 equals 6, or take the other parenthesis and say x minus 4 equals 6, kind of like we did above with the 0. That right there, however, is not true. There isn't a 6 product property like there is a 0 product property. 0 is kind of a special case. There are many ways we could multiply two things and get 6. This parenthesis could end up equaling 1, and this could end up equaling 6. That would give us 6. This could end up equaling 2, and this could end up equaling 3, and that would equal 6. There's a couple ways to multiply to get 6, and one of the two factors doesn't have to be 6. However, with 0, one of the two factors has to be 0. That's the only way we can end up getting 0. So this is, we're going to have to use a different approach. We'll look at that actually on the next page, how to finish a problem like that. But for now, I just wanted to show you if it doesn't equal 0, we can't apply that 0 product property. Okay, so those first three examples were kind of pre-packaged for us. They were in a nice form, what we call factored form, and set equal to 0. They're not always given to you in that form, and so we have to factor the expressions in order to get them into that form. That's why we learned all the factoring and reviewed all the factoring in 6.1, 6.2, and 6.3. So solving these next equations, we're going to actually have to factor. So this first expression, x squared plus 12x plus 20 equals 0. This is not written as something times something else equals 0 like they were up here. But we can get it in that form by factoring. So we want to factor to get it into the form where we have a times b equals 0. Something times something else, and their product equaling 0. Okay. We do already have it set equal to 0. We just need to get the equation, the expression on the left-hand side factored. So let me slide this up. So looking at that, x squared plus 12x plus 20, we learned in 7.2 or 6.2 how to factor something like that. Since there is no number in front of the x squared, all we care about is looking for the two factors, the two numbers that add to give us the middle term coefficient, the 12, but those same two numbers need to multiply to give us the constant on the end, the 20. Okay? So thinking about those two values shouldn't take very long to find that, well, 10 and 2 will do it. 10 times 2 gives us 20, so it satisfies that part. And then if we add 10 and 2, that equals 12. So it satisfies the second part. Okay. Then if you recall, we take those factors, 10 and 2, and we stick them in a parenthesis along with x. So it was a positive 10 and a positive 2, so that's going to factor into x plus 10, x plus 2. Again, because it is an x squared that's out front in our original expression, x times this x would give us that x squared, and we're good. X times 2 would give us 2x, 10 times x gives us 10x, those would add to give us the 12x, and then 10 times 2 would give us 20. Okay. Now we have our equation in the form a times b equals 0. One factor times another factor equals 0. So this tells us either x plus 10 equals 0, or the other factor, x plus 2, has to equal 0. And from that, we can easily solve both of these. It would take a negative 10 plus that 10 to get 0, so x would have to equal a negative 10. Or negative 2 plus 2 would equal 0. So in this case, x would have to equal negative 2. So there are two solutions to the equation, and we know that there's going to be two solutions because we have a quadratic. We have something to the x to the second power. That informs you how many solutions you're going to have in these equations. Okay. looking at the next example, we have another equation, set equal to 0, but this has a coefficient attached to the x squared. It has a number out front. So these, if you recall, take a little more detailed process to factor. We're going to factor by using what we call the divide and slide method. As we saw in section 7.2. Okay. So even though we're going to do a different method, it starts the same way. We consider what is our a value, that's the 4 attached to the x squared. Our b value is what's ever attached to the x term, and then c value, the constant on the end. So here we're not just looking for what number multiplies to get 1 that adds to get negative 4. We have to multiply our a times c. 4 times 1 in this case, which gives us 4. So we're looking for two numbers that multiply to give us that number, the AC value, that add to give us the middle value, b, of negative 4. Okay. So we need two numbers now that multiply to give us this, positive 4, and those two numbers have to add to give you negative 4. Okay. So thinking about that a little bit, hopefully we can come up with a pair, negative 2 and negative 2. When we multiply, those give us a positive. Negative times a negative is always a positive. But then when we add negative 2 plus a negative 2, it gives us the negative 4 we need to add to give that b value. So negative 2 and negative 2 are going to be the factors we use, just like we used 10 and 2 up here. So the next step is still the same. We could come here and throw those factors in a parenthesis with x. The factors were the same number in this time. X, and it's a negative 2, so x minus 2, and another x minus 2. Okay? Equals 0, technically, but we're still factoring, because we're not done here. This can't be the correct factorization, because x times x, if we FOILed this out, would give us x squared. And we have 4x squared. So here's where the divide and slide part comes into play. Okay? We have to divide the two factors we just found. Divide by the a value that we had in the original expression, which was 4. So our a value equals 4. We're going to divide our two factors that we plugged in with x by 4. And then at this point, we have to reduce our fractions. Okay. So if 2/4 reduces, we want to do so, and it will. 2/4 will reduce to 1/2. So we have x minus 1/2 and x minus 1/2. We have the same parenthesis factor twice here. But now what we need to do, because those reduced and we still have a fraction, since they didn't reduce to whole numbers, the dividing by 4 was the divide part. Here comes the slide part. We slide our denominators out in front of the x. So if you reduce your fraction and it doesn't reduce to a whole number and you still have a fraction, take the denominator, slide them out in front of the x. So this final factorization would actually be 2x minus 1, parenthesis, and another 2x minus 1, parenthesis. And now, since it's factored, I'm going to write in the actual equation, equals 0. Okay. So on this one, now we finally have it in that form we want. Something times something else equals 0. We don't need to solve it twice because it's the same factor, it's the same parenthesis. So let's go ahead and just solve it once. Okay. And in doing that, we can come over here. 2x minus 1 equals 0. Okay. Well, if we add 1 to both sides, we get 2x equals 1. And then if we divide by 2 on both sides, we get x equals 1/2. So even though it was another x squared situation, you're thinking there will be 2 solutions. X equals 1/2 is a double solution in this case. It kind of solves both of these two equations. So we can call it a double solution. We actually call this in math, we say that solution has multiplicity 2. We say it's a 0 of multiplicity 2 because it's the value that would zero out that equation. But for now, we'll just call it a double solution. And that's why in this case we don't have 2 x values, we just have 1. Okay, because we had that repeated parentheses factor. That means this is what we call a perfect square trinomial, if you remember from 7.3. Alright, so that was some of the basic equations. Now we'll look at the next page of these notes. Slide this back down. And here we have some trickier ones. Okay. So first example on this page, we have 3m squared equals 108. We need to solve this equation. So we want to use some sort of method we know. But first things first, we can't factor or anything like we were just doing because this equation is not set equal to 0. So that's the first thing we're going to want to do. Get the equation set equal to 0. Okay. So to do that, we'd subtract 108 from both sides, which would give us 3m squared minus 108. Now it's equal to 0. Okay. So we want to factor this expression on the left-hand side. It's only 2 terms, and it's subtraction, so it looks like maybe this would be a difference of squares, but 3 isn't a perfect square. However, we have a GCF we can factor out. In this case, the GCF is going to be a positive 3, because 3 will go into 3, and 3 will go into 108. It will divide both of those numbers cleanly. So if we were to divide the 3 out, we'd be left with an m squared to get us the 3m squared if we distributed back. And then 3 times a negative 36 would give us the negative 108 there. Equals 0. Okay. Now what we have left inside the parenthesis, that is a difference of squares. Okay. M squared is obviously a square, and then 36 is something that's a perfect square. Okay, it's square rootable. So now what we have left is difference of squares. So again, from 7.3 we learned how to solve these, how to factor these expressions, and how these will always factor is first put the 3 out front. It's going to factor into a double parenthesis, but as you see, there is no middle m term. There's an m squared term and a constant, but there is no middle m term, and that's the result of these two factors in parentheses being the exact same. The exact same except for their sign. They're just opposite signs. So we would need an m here and an m here to multiply to get m squared. And then we need 2 numbers that multiply to give us that negative 36, which are going to be a 6 and a minus 6. So because our 2 factors are identical, just opposite signs, this would, if we FOILed this back out, would get us back to the m squared minus 36. So now we have our equation in factored form. We have it set equal to 0. Now we can solve. This is a little different than the other examples we saw where we had a 3, but I think there was a 5a out front. If there's no variable out here with the 3, then that 3 plays no role in our 2 solutions. All that's going to matter is where there's a variable. So the m plus 6 and the m minus 6. Okay. I guess you could still think of it as the what do you call it? The zero product property. Okay, if we have 3 times a times b equals 0, well, still, whatever a and b is, a would have to equal 0 or b has to equal 0. it's still kind of using that zero product property. So the 3 doesn't really play much of a role. It's this m plus 6 that has to either equal 0, or the m minus 6 that has to equal 0. So this tells us our two solutions, which are that m either equals negative 6, because of that one, adding 6 to both sides here, m would equal a positive 6. Okay, so there's our two solutions. And I have in my notes another way my math lab sometimes has you write it, so I'm not sure if in this case that is you're going to be expected to fill in an answer on my math lab this way, but you will sometimes see this written in the set builder notation. M equals, they'll open up a set, and you have to fill in the values negative 6 and positive 6. Okay? So saying m equals negative 6 or m equals 6 is the same thing as saying that. Alright, looking at our next example, we have a double parenthesis on the left. It's nice, it's already in factored form, except that it's not set equal to 0. So that's a problem. We want to move these pieces over to the left, but we need them to be able to combine. We want it just to be a parenthesis, double parenthesis equals 0. When we move an 8 and an x over, we won't have just a double parenthesis. So what we need to do is we need to FOIL this left-hand side out. Okay. So x times x is going to give us x squared. X times negative 2 will give us negative 2x. 6 times x gives us a positive 6x. 6 times negative 2 gives us a minus 12. Okay. That equals negative 8 plus x. We could go ahead and simplify the left-hand side of this equation. Negative 2x plus 6x gives us a positive 4x. And now we want to get this equation, we want to set it equal to 0. So we will add an 8 to both sides. This gives us x squared plus 4x minus 4 equals x, because the 8 will cancel there. And then to cancel out that positive x, we would need to subtract an x from both sides. That would cancel it out there and give us the 0 we want, and then we have to subtract it from there, the 4x. So on the left-hand side, we now have x squared plus 3x minus 4 equals, x's cancel, 0. So now we have everything combined. Now we want to factor. We're looking for two numbers because there's nothing in front of the x squared. So we can go right to this process. Two numbers that add to give us 3, multiply to give us negative 4. Okay. Those numbers are going to be negative 1 and positive 4. Those add to give us the positive 3, so it checks there. And then if we multiply negative 1 times 4, they multiply to give us negative 4. Okay. So negative 1 and positive 4 are the two numbers we want. This tells us what we have is going to factor into a double parenthesis equaling 0 of x minus 1 and x plus 4. Alright, so now we have a times b equals 0. Something times something equals 0. Let's apply the zero product property, setting both factors equal to 0. So this tells us that either adding 1 to both sides here, either x equals 1, subtracting 4 from both sides, or x equals negative 4. Okay. So there's our two solutions for that example. Alright, so we have one more we have to look at. for this page. Then we'll probably cut the video at that point. This expression, negative x cubed plus x squared equals negative 6x. First things first, like all these problems, we want to get it set equal to 0. Okay. So we would do that by getting this minus 6x onto the other side, canceling it out to make this right side equal 0. We would need to add 6x. Add 6x. Okay. Well, none of these terms are like terms. They're all different powers of x, cubed, squared, and a single x. So we can't combine anything. We just write them all out as 3 terms now. On the right hand side, those cancel. We have ourselves a 0. Okay. Well, factoring we can't do the same way because this is an x cubed term. We need this. We need it to be an x squared and x in a constant in order to factor the way we did right here. But what we can do, they all have at least a single x in them, so we can factor out a GCF. In this case, GCF, they all have an x. However, when we have a negative leading term, we also would like to factor out a negative to make this become a positive leading term. So we want to factor out a negative x. Okay. That is going to give us negative x, parentheses. It's going to leave us an x squared, okay, because negative x times x squared would give us negative x cubed. Negative x times another negative x would give us positive x squared. And a negative x times a positive 6 would give us negative 6x. Okay. Now that we pulled out the negative x, what is left inside the parentheses is of something we can factor. It is of the form we want. So we need 2 numbers that will add to give us, technically that's a negative 1 there, that multiply to give us a positive 6. Okay. These numbers are going to be negative 3 and a positive 2. Those add to give us negative 1. They multiply to give us a negative 6. So negative 3 and 2 are the numbers we want. Because we don't have a number in front of the x squared, it's just a single x squared, we can use that and just stick the factors in parentheses with x. So we already had the negative x out front. That we've GCF we factored out. Now we're creating 2 more parentheses. X minus 3 and x plus 2. Because it was a negative 3 and a positive 2. So there's our factored form. We have something times something times something equals 0. We can apply that 0 product property one last time. So this tells us either negative x equals 0 or x minus 3 equals 0, or our third factor, x plus 2 equals 0. And so from this, we can come up with 3 solutions. We had an x cubed, x to the 3rd power. That's why we're getting 3 solutions on this one. So from this tells us, well, if negative x is 0, if we divide by negative 1 on both sides, well, it tells us x has to be 0. Adding 3 to both sides here tells us that x could equal a positive 3. Or lastly, subtracting 2 from both sides, x would equal a negative 2. So on that example, we end up getting the 3 solutions, again, because we had x to the 3rd power in our original equation. Alright, I think that's good for now. In the next video, I will finish up section 6.5 with the word problems, the 2 word problems on the last page.